Alrighty, the first question here we have y equals sine of ln of 3x squared, and because we have so many ofs in a row, we've got a chain rule scenario going on. So I'm going to start by saying let u equal ln of 3x squared, and therefore du dx is going to be 6x over 3x squared, which can simplify down to 2 over x. So a good start. Next thing we're going to do is say if u equals that, then this implies that y equals sine of u, and therefore dy du here is going to be cosine of u. So with that in mind, I'm now going to write my chain rule, which is dy dx equals, and we're going to have du dx multiplied by dy du. So you can see here that if we had these du's cancel out, then we have dy dx on the right hand side, which means that the right hand side equals the left hand side, so the chain rule works. Right, so now we have to sub in our values, so we get that equals 2 over x times by cosine of u, which I'll just leave as u for now, and I'll finish by saying that's going to be 2 lots of cosine of, now u was ln of 3x squared, so I'm going to sub that in here and say ln of 3x squared, close bracket, all that is over x. And that's my final answer for the derivative of y equals sine of ln 3x squared using the chain rule. Alrighty, the next one we've got here is y equals ln of 4x cubed plus 3x, and then that's being multiplied by e to the power of 2x minus 3. If we have a multiple here, or otherwise known as a product, we have what we call a product rule. Okay, so similar to the chain rule, we're going to say some things. I'm going to say this is going to be u and this is going to be v, and we're going to find their derivatives. So I'm going to say u equals ln of 4x cubed plus 3x. du dx is going to be, now with a log, when you derive it, or natural log, when you derive the inside, it's going to be that over the original. So the inside derived is going to be 12x squared plus 3, and that's all going to be divided by the original function, 4x cubed plus 3x. Now, unfortunately, we can't cancel anything out like these 3's or these 12's and 4's because we have a sum on the numerator and on the denominator. No can do. That's as simple as this guy gets. I suppose we could factorize the 3 out of the numerator, but it doesn't really change much. Next, we're going to say let v equal e to the 2x minus 3, and therefore dv dx is going to equal 2 lots of e to the power of 2x minus 3. Nice and easy. So now our product rule is dy dx is equal to, we've got v times du dx plus, that's a multiple there, plus u times dv dx. Now you can change the order of these two as long as v is multiplied by du dx and u is multiplied by dv dx. You can change the order of these because we have an addition here in the quotient rule, which is up next, so stay tuned. That's not the same, so make sure you keep watching. So now we're going to sub in our values here. So v is e to the power of 2x minus 3. I'm going to put some brackets here for clarification, multiplied by du dx, which is this entire guy up here. Save a bit of time, power of technology. Let's duplicate and put it down here. I'm even going to drop this down one line because I'm going to run out of space. All right, so that's v times du dx. Now we're going to add on u, which is going to be ln of 4x cubed plus 3x times by dv dx, which is 2 lots of e to the power of 2x minus 3. Also close the brackets. From here, we want to be able to simplify these types of questions. So we're going to look for a common factor in both, of which there is one. It's this e to the power of 2x minus 3. It appears in both of my terms here. This is one term, this is another, and that appears in both. So we can factorize that out just to tidy it up, and we get e to the power of 2x minus 3 multiplied by both of these terms. So on the left-hand side, we just are going to copy and paste this guy down. So duplicate him down here. And then plus 2 lots of this 2 that's out the front, ln of 4x cubed plus 3x. And that is my final answer for the derivative of y with respect to x. And lastly here, we're looking at a situation where we have a division and both the numerator and denominator are a function of x, and hence we have a situation where we're going to need the quotient rule. Okay, so in this one, we're going to have the numerator can be u, the denominator can be v. And so we're going to have u equals 6x squared minus 3x plus 2. du dx therefore is going to be equal to 12x minus 3. V is going to be equal to sine of 2x. dv dx is equal to 2 lots of cosine of 2x. And lastly, we're also going to have v squared is going to be equal to sine squared 2x. So dy dx, in fact, I'm going to do this further down below because we're going to run out of space. So down here, I'm going to write dy dx. dy dx is going to be equal to, now this is where the order does matter. We're going to have to say v times du dx first. So v times by du dx minus, and this is why the order is important because we have a subtraction here, minus u times dv dx. So u times dv dx. Okay, all of that is going to be divided by v squared. So let's go ahead and substitute in our values. V is sine. In fact, I'm going to speed this right up here and say if I'm going to get v, I'm going to be getting sine of 2x. Put that down here. Times by du dx, which is going to be my 12x minus 3. Subtracting u, which is going to be this expression up here, times by, and keep in mind it's that entire thing, that entire u is being multiplied. In fact, this is also in a brackets here. That's going to be multiplied by dv dx, which is going to be this term here. Duplicate that. And all of that is going to be over v squared, which is this term here. Now it's nice and easy on technology to go ahead and just grab all of those terms and put them in. If you're on pen and paper, sorry, you're gonna have to write them all out. Okay guys, hopefully that is helping you understand more about the chain rule, the product rule, and the quotient rule in terms of some more challenging derivatives. Notice though, no matter how hard the derivative, there is a process that we go through. We establish u and v, we derive them individually, we substitute them into the formula, and we simplify where possible. No matter how tricky it gets, it's that process over and over and over. So hopefully you got something out of this. If you did, make sure you like the video. Comment down below if you found any of those particularly challenging, or if you have any questions that you'd like me to make in a subsequent video, that would be great too. Otherwise, I'll see you in the next one.